Hello, and welcome to our fourth class of our course on data visualization. In the previous classes, we have presented the area, the main methods to visualize data distributions and associations among variables. In this class, we are going to present graphs that allow us to compare different values of one or more variables. Let's have a look now at amounts. Amounts here, we are going to work with bar charts and the radar chart. As I mentioned before, bar charts are a way of visualizing the distribution of categorical variables. Okay, so they can be used, the bar charts can be used to visualize data that can be clustered into discrete categories. So that's why they are used with categorical or discrete data. And the interpretation is equivalent to the interpretation that we have with histograms, in the sense that the size of the bar represents the count of each category that we have in a variable. And here, for example, I'm showing the bar chart for the shape and severity. Note that I have two variables here. The question mark represents value that, or a category that is unknown, because there is no value in the data set. There is a missing value there. But here I can see that for the category irregular and benign, this is the mammographic data set. And what we are showing here is the number of objects or the number of samples. In this case, each object corresponds to a patient. So what I can read from this bar chart is the number of patients that present the image of their breast cancer mammogram with a shape that is irregular, but that is classified as a benign image or a benign type of tumor. Here we have irregular and malignant. We have shape lobular and benign, shape lobular and malignant, and so on and so forth. And here I count the number of patients in each of these categories. In this visual here on the right, I am basically showing the same thing, with the difference that now I am using a clustered bar chart. In this clustered bar chart, I am separating the malignant, which is the orange one, from the benign. And we can see, for example, that if I have an irregular shape in my mammogram, the probability of being malignant is much higher, because I have a much larger number of patients that have a irregular shape and that were diagnosed with a malignant type of tumor. Okay, so in this bar chart here, I fused, or I combined the shape with the category or with the classification of the mammogram. And here I separated it. Here I am using only the shape, and the category I'm showing by a different type of color, either blue or orange. And this is simply a bar chart counting the number of samples that I have in my data set for each of the two classifications, benign and malignant. The radar chart is very interesting as well, because it allows us to compare and to visualize different series of continuous variables in one single radial chart. It's usually used for continuous data. And what we have is, when we define what are the variables that we are going to observe, and we plot them in the radar chart, and I plot the radar chart for the objects that I have in my data set, I have a polygonal shape, or I have a polygon. And this polygon allows us to compare different series of variables. Let's have a look at an example. This is the example for the iris data set. And we know that in the iris data set, we have three classes of plants. We have iris setosa, iris versicolor, and iris virginica. What I'm showing here is the sepal width, the sepal length, the petal width, and the petal length. These are the four independent variables that we have in the data set, if you can remember that. And what I'm plotting here is the average value of each of these variables for each plant species. So as we can see, the iris setosa is quite different from the other two classes. And this was observed. We saw that in the scatter plot, for example, right? And the difference, we saw how similar these two species are and how different they are from the iris setosa. So this is also observed here in this graph. Let's have a look at another example of how to use the radar chart. Here I am presenting you 6 different careers within data science: a business analyst, a data analyst, machine learning engineer, a data scientist, a data engineer, and the chief data officer. What I'm plotting is, for each of these careers, I am plotting the skills or the knowledge of each of these professionals in predictive statistics, descriptive statistics, visualization, storytelling, business analysis, databases, software engineering, and programming. So here on the left, we have the more programming-based skills. Here we have the more mathematical skills. Here we have the more business-oriented skills. So when we look at the data analyst, for example, the data analyst have to have much more knowledge and skills related with business and visualization, and a little bit of computing, a little bit of maths and statistics. But this professional has to be much stronger in this type of skills. On the other side, if we look, for example, at the data scientist doesn't have to be so skilled, for example, in business or in storytelling, but it has to be much more skilled in terms of maths and statistics, and it has to have more skills also in the computing side. Okay, whilst the machine learning engineer has to have even more skills from the computing side, because one of the things that differentiate ML engineers from data scientists is that ML engineers are usually more focused on designing new algorithms and testing new things, whilst usually data scientists, they're more on the training, the analysis, the evaluation of models. Okay, but these are 2 careers that are very similar to one another. We can see that they have to be well-versed in maths and also well-versed in computing. Okay, so this is just to illustrate to you how we can use the radar charts to compare these different careers. Thank you for watching this introductory course on data visualization. Do not forget to subscribe and look at the other courses and series available in the channel.